Hello guys, my name is Mikhael Tambunan. Before we start, click the subscribe button, like and share for more interesting information. In this video presentation about theory graph. Enjoy it. In mathematics, graph theory is the study of graphs, which are mathematical structures used to model pairwise relations between objects. A graph in this context is made up of vertices, also called nodes or points, which are connected by edges, also called links or lines. A distinction is made between undirected graphs, where edges link two vertices symmetrically, and directed graphs, where edges link two vertices asymmetrically. Graphs, where edges link two vertices asymmetrically. The paper written by Leonhard Euler on the 7 bridges of Königsberg and published in 1736 is regarded as the first paper in the history of graph theory. This paper, as well as the one written by van der Mond on the ninth problem, carried on with the analysis situs initiated by Leibniz. Euler's formula relating the number of edges, vertices, and faces of a convex polyhedron was studied and generalized by Cauchy and L. and represents the beginning of the branch of mathematics known as topology. More than 1 century after Euler's paper on the bridges of Königsberg, and while Listing was introducing the concept of topology, Cayley was led by an interest in particular analytical forms arising from differential calculus to study a particular class of graphs, the trees. This study had many implications for theoretical chemistry. The techniques he used mainly concerned the enumeration of graphs with particular properties. Enumerative graph theory then arose from the results of Cayley and the fundamental results published by Polio between 1935 and 1937. These were generalized by de Bruin in 1959. Cayley linked his results on trees with contemporary studies of chemical composition. The fusion of ideas from mathematics with those from chemistry began what has become part of the standard terminology of graph theory. A graph coloring is an assignment of labels, called colors, to the vertices of a graph such that no two adjacent vertices share the same color. The chromatic number G of a graph G is the minimal number of colors for which such an assignment is possible. Other types of colorings on graphs also exist, most notably edge colorings that may be subject to various constraints. The study of graph colorings has historically been linked closely to that of planar graphs and the four-color theorem, which is also the most famous graph coloring problem. That problem provided the original motivation for the development of algebraic graph theory and the study of graph invariants such as those discussed on this page. In modern times, many open problems in algebraic graph theory deal with the relation between chromatic polynomials and their graphs. Applications for solved problems have been found in areas such as computer science, information theory, and complexity theory. Many day-to-day problems, like minimizing conflicts in scheduling, are also equivalent to graph coloring. The chromatic number of a graph is the minimal number of colors for which a graph coloring is possible. This definition is a bit nuanced though, as it is generally not immediate what the minimal number is. For certain types of graphs, such as complete Kn or bipartite Kmn, there are very few choices possible, and so it is possible to determine, for instance, that Kn equals n since each vertex must have a different color than the rest. The minimality component of chromatic numbers is useful for proving many basic theorems quickly, as it allows a focus on extreme, instead of general, cases, here, graph colorings that minimize the number of colors. It is for precisely that reason that mathematicians prefer such definitions. A graph G is called K-colorable if there exists a graph coloring on G with K colors. If a graph is K-colorable, then it is n-colorable for any n greater than naught. A graph has a chromatic number that is at least as large as the chromatic number of any of its subgraphs. A graph has a chromatic number that is at most 1 larger than the chromatic number of a subgraph containing only one less vertex. The most common type of edge coloring is analogous to graph vertex colorings. Each edge of a graph has a color assigned to it in such a way that no two adjacent edges are the same color. Such a coloring is a proper edge coloring. With cycled graphs, the analogy becomes an equivalence, as there is an edge-vertex duality. In general, however, the chromatic number is not related to the minimal K such that a proper edge K coloring exists. Another type of edge coloring is used in Ramsey theory and similar problems. In such cases, edges of the graph are colored one of K colors and mathematicians investigate the resulting colored graph substructures to determine what sizes of complete subgraphs exist. A final type of edge coloring is used in the study of spanning trees. Edges are colored in such a way that there does not exist a cycle of the same color, and the minimal number of colors required for such an edge coloring of a given graph is known as its arboricity. Thank you for watching. See you next time on the next video.